Okay, question number 1. Give me the set notation. Question number 2. Question number 3. Draw it. And 4, you're going to draw it. Try those 4 out. So, this first one is the crescent moon. Make sure your phones are away and you're paying attention. If it is the crescent moon is that an intersection or a union? Intersection. It needs to be an and because it needs to be a smaller piece. We agree? So at the very least, we got that. Then we know one of them has to be a complement and one of them has to not be a complement. I need it to be n, correct? So n will be n and m complement will be the one. Now you could write it like this. That means the exact same thing, correct? You could have them on either side. It does not matter. It just means that the m has to be the not because it's not in m. Number 2 is what shape? The snowman. And the snowman is what? 4. We agree. All right. This one can be written. This one can be written as not m, not n, and the and would turn to an or. We agree? It can be written like that. The only time you would do that is if they forced you to that. That is not helpful. This way is easier. The way I gave you is easier. Because what we do is we say, okay, what is M and N? M and N is what shape? The eyeball. And I want not there. So everywhere else. We agree? This is the eyeball. I want not the eyeball. So everywhere else. So I'd say, here's my eyeball. And no thank you. Okay? So you could go this route, shade each separately, and you would end up with this. But this way's easier. Okay. What happens if you get an M and a complement with an or symbol? You actually get everything but the crescent moon. So with an and, you get only the crescent moon. With an or, you get everything but the crescent moon. So we're going to go M, N, and which crescent moon do I not get? Do I not get the N or do I not get the M? Which one has a not? The N has a not, correct? So the only crescent moon I'm not going to shade is N. Everything else will be shaded. Now, could we just shade each separately and call it a day and not think about crescent moons? Still get the same answer? Yeah. So what could I do? I could go M, N, and I could shade M. Guys, I can hear you talking, which means so can the podcast. Not N means this circle. And everything else I know. So you shade the same stuff, right? So you could do it that way as well. Okay. 2 more questions we're going to go through. Number 5. Timmy surveyed 27 people. Loved cats. 20 loved emus. And 3 loved, not 3, that's more than 3. We'll say 6, loved neither. How many people loved emus only? So, here we have 2 circles. Not very well drawn. Cats, emus. How do I figure out how many are in the middle? Add everything together because I gave you the people who put in tickets for emus and loving cats, loving neither. And so that's going to be 14 plus 6 plus 20, which is 40. However, how many people did I survey? Not me, Timmy. Timmy surveyed 27. So we subtract them off and we get 13 in the middle. How many like cats only? 1. There's a lot of emu lovers in the mix. How many liked emus only? Love emus only? 7. And then we had 6. So our answer would be 7 people love emus only. Did everyone look at what an emu is? You didn't see an emu? Kind of like an ostrich almost. Yeah. All right. Did you sign in, Chloe? Okay. 6. Let's discuss this one. All right. So what we're going to do here is we're going to do a what do you think I'm going to give you? Yes. Got our A game today. Okay, 3 circle Venn diagram. So I'm going to do it this way. I'm going to say 200 people surveyed. $150 liked running or jogging. 60 liked running. 20 liked jogging only. That's a lie. Like skating only is what I meant to say. 4 people liked all 3. 10 people, I don't know why I switched to people now, liked running and jogging. 8 people liked jogging and skating only. 4 people liked running and skating only. I want to know how many people liked neither. Like none. Actually, like none of the 3. So we have a 3 circle Venn diagram. Everyone should be paying attention. And we have Running, jogging, and skating. Where do we always have to start? Where do we have to start? In the middle in the alls. So how many are in all? 4. But then after that, if there are any onlys, or even before that, if there are onlys, you can do those right away, correct? Because onlys get just put into a spot. Hopefully the correct one. So here we have 8 people like jogging and skating only. So I can go to the jogging and skating. The only piece is this piece here. So in jogging and skating, they should have an 8. It should not be subtracted. Then 4 people liked running and skating only, so I go to the running and skating only eyeball, but the only piece is just this little piece here, so it should be a 4. Remember, you're not subtracting if the word only is there. Then it said 10 people liked running and jogging. So in the running and jogging eyeball, I should have 10. I already have 4, so this is one I actually subtract, so I get 6. 20 liked skating only, so I get a 20 here, correct? Because it says only. Then there's running left or running or jogging. I have to do the ors last always. So in the running circle, in this circle I should have 60. I have 18. So what is this? Oh, that's a lie. I did the jogging for the running. Running is here. In running I have 14. So what should I have here? 46. And then I go to the or, and the or is actually the snowman. It's the last one. So I should have 150 in here. I currently have 50, 68. So how much is in just jogging only? Pardon? 82. Now I need to have 200 people. So this is 150, 160, 170. How many are out here? 30. So 30 people. None of the 3. Okay, I'm going to get you to flip through your notes from yesterday. We're going to do a tree diagram again today. So here we have the football team has the following kit: a jersey in red or black, pants in white, red, or black, and socks in red. So remember that for your tree diagram, you actually have to fill in along the top the titles. So you're going to have jersey, pants, socks. Now the key thing in order to do these is they have to pick one of each. So let's make sure they do. The team plays in a different uniform each week until it has to repeat a previous uniform. A uniform consists of a jersey, pants, and socks. So you just need one of each. So that's how we can use the tree diagram or the fundamental counting principle. Now remember, we have to start with the first ones working down. So we have red with a space, and then we have black. And the reason why we have the space is because off of each of these I'm going to have how many little branches? Next is pants. How many different types of pants are there? 3. So now I'm going to have 3 colors of pants off of each of these. So I'm going to have white, red, black. And if we stopped at just the jersey and pants, we would have 6 different outfits, right? But now they add socks to the mix. How many different socks branches am I going to have off of each of these ones? 1, because I only gave 1 type of socks, right? So we're going to have red, red, red. So this physically shows 6 different outfits. You can actually see the different colors of each of the items, correct? You can actually see the outcomes. And this is helpful for probability. So I'll show you, there's a question on the next side, which this will be helpful for. But if I just asked you for how many different outfits, do you actually have to show every single outcome? No, you just need to know how many, correct? So that's how we can use the fundamental counting principle. When we need parts, different parts that make up the whole, and we need every single part. So in order to make this whole outfit, I need a jersey, and, which I told you is multiplication, pants, and I need socks to make this outfit. The blank represents one of each. So if I need one jersey, I do this, one pair of pants, one type of socks to make the outfit, I do the blanks. If I need more than one of each, I can't do this, because I can't like stack a blank on top of another blank or something like that, right? A blank represents one jersey, one pair of pants, one thing of socks. If I want to take like 2 different types of pants, I don't know why you're layering, maybe to make it warmer, then you can't do fundamental counting principle. We have to be able to pick one of each in order to use fundamental counting principle, which is these blanks. So on the top, we list our options. How many jersey options? 2. How many pants options? And sock options? So we have 6 different weeks. 6 different outfits. So after 6 weeks, they're going to repeat. Because here it says, determine how many weeks the team can play before repeating a previous uniform. The team can play for 6 different weeks before repeating a previous uniform. We're going to flip over for the next side for one question, and then we're going to come back. Why is your phone? All right, we're going to flip over. So the next side, this is a question that goes with this question. Then we're going to go back and make you do the tree diagram of the previous example. But this one says extension. What is the probability of wearing a color rush outfit? A color rush outfit, they have it in the NFL all the time where you have like all the same colors. They're like all baby blue or whatever it may be. So in order to have a color rush outfit, we have to have all the same colors for the whole outfit, correct? So that's when actually drawing the tree diagram is helpful, because then you actually can see what the different outfits look like. The fundamental counting principle just says, hey, there's 6 of them. We don't really know what they look like. We just know there's 6 different ones, right? But the tree diagram itself actually shows the different 6 outfits. So let's go here. How many of these are color rush outfits? How many of the 6? Just 1. We only have red socks, correct? So the only color rush outfit is going to be the red, red, red one, which is this one here. So how many is that for probability? 1 out of 6. Then I'm going to get you to flip back a page. We didn't do this yesterday because we ran out of time. I want you to do it today. I want you to show me the tree diagram of the 12 different robots. So remember, you work along the top. So along the top, you're going to have part 1. Then you're going to list those parts with space. Then part 2 are going to be the branches off part 1. Then part 3 are the branches off part 2. So try it out. See if you can do it. So for here, if Jeremy wanted to go shopping for pants to make sure he had enough different outfits, An outfit must have a shirt, a pair of pants, and a pair of socks. So I know we need one of each, so I put the blanks and I can use fundamental counting principle. To not repeat the same outfit for 48 days. So I gave you the total. In his closet there are 8 shirts, 2 different pair of pants, and I'm asking 2 different socks. I'm asking you how many pants. So you could say 8 times 2 is 16x equals 48. Divide by 16, and x would equal 3. And then the last one is a 6-question multiple choice quiz. So 1, 2, 3, 4, 5, 6. Be number 1, 2, 3, 4, 5, 6. But how many options do I have on the top? 4, 4, 4, 4, 4, 4, which is 4,096.